Under the cover of the dark, a pair of Ukrainian fighter jets were reported to embarked on a perilous mission, expertly skimming below the enemy's radar detection. In their arsenal, they carried 10 formidable Storm Shadow missiles jointly developed by British and French engineers. Regrettably, the success of their mission would not go unchallenged. The Russian air defense systems sprang into action, intercepting and obliterating 7 of the incoming missiles before they could even draw close enough to inflict any harm. However, amid the chaos and flashing anti-aircraft fire, 3 of the Storm Shadow missiles managed to elude their adversaries' defenses. Their targets were a formidable Ropucha-class amphibious vessel and a menacing class submarine, both vital components of the Russian naval fleet. The precision strikes unleashed devastation, causing extensive damage to both the amphibious vessel and submarine, dealing a significant blow to Russian maritime capabilities. But that's not all. A few speedboats or possibly sea drones were also launched at the port in Sevastopol. However, reports indicate that they were either damaged or failed to complete their mission due to the upgraded defense systems, or it might have caused only little damage to the other vessels. Let's look at how its weapon system works. As stated, the Storm Shadow or Scalp missile have 2 warheads, a precursor at the front, and the second one is the follow-through bomb. Let's consider this landing ship as a target, which is composed of 2 layers of steel. Step 1. Contact sensor detects a target. Step 2. Armor-penetrating precursor blasts jet of hot metal through up to 4 to 5 meters or 16 feet of steel. Step 3. Follow-through bomb separates from the missile and penetrates the ship. Step 4. If the fuse is set in delay mode, it will explode within the ship, maximizing the damage inside it. This damage can even sink a ship or render it unusable for several days. This missile has a length of 5.2 meters or 17 feet, while it has a breadth of 630 millimeters or 25 inches, but opening its wingspan measures around 3 meters or 9 feet 8 inches. It weighs around 450 kilograms or 900 pounds. Comparing this to a person will help you understand its size. Even better, let's compare this to the American cruise missile or the Russian missile. As you see, it looks a lot smaller than its counterparts. Also, not to forget, it looks a lot similar to the small diameter bomb when it opens its wing, animated in our recent video. Let's take a look at the interiors and parts of the missile. At the front is the sensor cover, just beside it is the standoff fuse. Sandwiched between it is the infrared sensor and IMU, or in full form the inertial measurement unit, which helps calculate the IMU work in part by detecting changes in pitch, roll, and yaw. Here lies the weapon activating switch or sensor. Just like the Javelin missile, it has a 2-weapons payload. This is the precursor bomb, and just behind it is the follow-through bomb. Moving to the back, the cylinder-looking object is the accumulator, which is a storage device in a hydraulic circuit to draw quick energy when required. This is the air intake extension. It runs all the way towards this engine fitted with this microturbo TRI-60. It is a small, expendable turbojet engine developed by France. Let's move to the back of the missile. These are the 2 dorsal fins. Just beside it is the horizontal control surfaces. Moving below them are the ventral fins. But how do cruise missiles fly without traditional wings? Unlike standard aircraft, cruise missiles do not have advanced wings for lift and control. Instead, they rely on advanced propulsion systems, aerodynamic design, and sophisticated guidance systems to navigate and maintain stable flight. Here's a simplified explanation of how cruise missiles fly without advanced wings. Propulsion. Cruise missiles use jet engines, ramjet engines, or rocket motors for propulsion. These engines generate thrust to propel the missile through the air. Control surfaces. Although cruise missiles lack traditional wings, they have control surfaces, such as fins and flaps. These surfaces can adjust their positions during flight to control the missile's direction, stabilize its flight, and make course corrections. This system uses an IR seeker, a thermal homing head, and a terrain contour matching. Calculates the necessary adjustments to maintain the desired trajectory. By combining these elements, cruise missiles can achieve stable and controlled flight over long distances without the need for conventional wings. They rely on aerodynamic principles, propulsion systems, and advanced guidance technologies to reach their targets accurately. For now, we will look at the steps-by-steps format of how this works. Step 1. Aircraft releases the missile. Step 2. After a few seconds, the missile opens its two wings. Step 3. It first uses inertial and GPS for guidance at the first stage of the missile. Step 4. Drops to low cruising altitude and identifies its position using GPS, just like the animation shown here. As you can see, it flies below the radar and close to the hills and ground. Step 5. At the final stage, a thermal homing head and a terrain contour matching are used to guide the missiles. This is how it works. It uses the IR sensor imaging infrared seeker to track and process images, helping it glide to its target. Step 6. It climbs to a higher altitude. This helps the command and control to even monitor the target in the dark using a two-way data link. For the final maneuver, the nose cone is jettisoned to allow a high-resolution thermographic camera or infrared homing to observe the target area. The missile then tries to locate its target based on its preloaded data information. If all is approved, it then dives to destroy the target. Simplifying it in one frame. Missile detaches from aircraft. Drops to very low altitude and uses GPS and digital terrain matching technology to hug land contours, staying below. At the final stage, a thermal homing head and a terrain contour matching are used to strike the target. Let's look at the pros and cons of this cruise missile. Precision and accuracy. The Storm Shadow missile has a high degree of accuracy due to its advanced guidance system, which includes inertial navigation, GPS, and terrain reference matching. Range. The missile has an impressive range of over 250 kilometers or 155 miles, allowing it to strike targets from a safe distance. This extended range allows it to engage targets deep inside enemy territory. High lethality. The Storm Shadow missile is equipped with a highly effective warhead, typically a 450 kilogram or 1,000 pound. Let's look at the cons or disadvantages. As stated, this is a cruise missile, so its speed is very slow compared to a subsonic missile. It can also be destroyed by a simple anti-aircraft weapon. The size and weight of the Storm Shadow missile restrict its capacity on platforms. This limits the number of missiles that can be carried, potentially reducing the number of targets that can be engaged in a single mission. Response time. The Storm Shadow missile, like other cruise missiles, requires a certain amount of time to reach its target, rendering it useless if the target is mobile. We make original 3D animation from scratch with 2 people working on it full-time. So please support us by subscribing to help us produce more videos just like this animation here.